Now let us look into the third question. Design Verilog HDL to implement simple circuits using structural, data flow and behavioral model. The expression, let us take an sample expression as y is equal to AB plus CD. Um, AB will represent it using the AND gates, and CD also will represent it using the AND gate, and the output from two AND gates will be the input to the OR gates, and input will be the desired output we get. The Verilog program for the expression we took will be of three types: the structural gate level, the data flow model, and the behavioral model. To construct behavioral model, we need to first look into the truth table. From the truth table, notice that A is equal to 1 and B is equal to 1. You will get the output as 1. Else if C is equal to 1 and D is equal to 1, you will get the output as 1. Or else if you don't have any other cases, you will get the output as 0. And finally end module. Similarly, the data flow model and the structural gate level. In the structural gate level, you will take input as B, C, D and output as Y, and you will take two wires, output 1 and output 2. Output 1 will be the wire from the outputs A and B, and output 2 will be the outputs from C and D. AND gates of A and B and AND gates of C and D, and finally OR gate of output 1 and output 2, and then finally end module. In data flow module, you will take A, B, C, D as input and Y as output, and assign A and B or C and D, and finally end module. When you look into the output, you will get it as when A is equal to A is equal to 1, B is equal to 1, C is equal to 1, and D is equal to 1, then the output will be 1. The same is represented here as well. And when A is equal to 1, B is equal to 0, C is equal to 1, and D is equal to 0, then Y will be 0 as well. The same is represented in this diagram as well.